In this lecture, we are going to discuss the Laplace transform of some basic functions and linearity property of Laplace transforms. Laplace transforms of some basic functions. First one is L of 1 is equal to 1 by s. Laplace transform of the function 1 is equal to 1 by s. We already proved this in the previous lesson. Also, we proved that L of t is equal to 1 by s square. Okay, in general, we have L of t power n is equal to n factorial divided by s power n plus 1. In general, Laplace transform of the function t power n is equal to n factorial divided by s power n plus 1 for n equal to 1, 2, 3, etc. So, when n is equal to 1, we have L of t equal to 1 factorial divided by s power 1 plus 1, that is s square, that is 1 by s square. We already proved that by using the definition of the Laplace transform. If n equal to 2, then we have L of t square is equal to 2 factorial divided by s power 3. L of t cube is equal to 3 factorial divided by s power 4, etc. Okay. Next one is L of e power at is equal to 1 by s minus a. This also we proved in the previous lecture. Okay. The Laplace transform of the exponential function e power at is equal to 1 by s minus a. Here is e power at, right? So L of e power minus at will be 1 by s plus a, replacing a by minus a. Okay. Also we proved that L of sin kt is equal to k by s square plus k square. Sin kt is equal to k by s square plus k square, right? And the Laplace transform of a cosine function cos kt is equal to s by s square plus k square. For sine function sin kt it is k by s square plus k square, and for cosine function it is s by s square plus k square. Okay. Next one is L of sin h kt. Hyperbolic sine of kt is nothing but k by s square minus k square. Here is minus. For hyperbolic functions, the Laplace transform is hyperbolic sine. We have k by s square minus k square, and L of cos h kt. Hyperbolic cosine of kt is nothing but s by s square minus k square. So you can apply these formula to solve the problems. Okay. Next, we have an important property of the Laplace transform, which is linearity of the Laplace transform. Okay. Suppose we have two functions f of t and g of t with the Laplace transforms L of f of t is equal to f of s and L of g of t is equal to g of s. Then the linearity property is nothing but Laplace transform of a into f of t plus b into g of t, where a and b are constants, is nothing but a into L of f of t plus b into L of g of t. That is equal to a into f of s plus b into g of s. This is the linearity property of Laplace transforms. From this we can say that the operator L is a linear transformation. Okay, or is a linear transform. L is a linear transform. Now, to prove this, we can just apply the definition of the Laplace transform. So, by the definition, we have L of a into f of t plus b into g of t is nothing but integral 0 to infinity e power minus st into our function is a f of t plus b g of t. So a into f of t plus b into g of t, right, dt, which is equal to we can split this, that is integral 0 to infinity e power minus st into a f of t dt plus integral 0 to infinity e power minus st b g of t dt. So from this we can take a outside because a is a constant. So this is integral 0 to infinity e power minus st into f of t dt plus b can be taken outside, b into integral 0 to infinity e power minus st g of t dt. Okay. So this integral is nothing but L of f of t. So this is equal to a Laplace transform of f of t plus b into, this is nothing but Laplace transform of g of t. This is equal to a into f of s plus b into g of s. So this is the linearity property of the Laplace transform. So from this we can say that the operator L is a linear transform. Okay. For example, find the Laplace transform of 1 plus 2t plus sine 3t. Okay. So how can we find the Laplace transform of this? This is actually the combination of three functions, 1, 2t and sine 3t. So we have this by linearity property, we have this is equal to L of 1 plus L of, that is 2t can be written as 2 into L of t plus L of sine 3t. Okay, so this is equal to, we know L of 1 is 1 by s plus 2 into L of t is 1 by s square plus L of sine 3t. We know sine kt, L of sine kt is k by s square plus k square. So this is 3 by s square plus 3 square, that is s square plus 9. So we have this is nothing but 1 by s plus 2 by s square plus 3 by s square plus 9. So this will be the Laplace transform of this function. Okay. Next question. Find the Laplace transform of t power 5 plus 5 cos 2t plus e power minus 5t plus 7 sin h of 2t. Okay. So here by using a linearity property we can write this Laplace transform of this function is nothing but L of t power 5 plus 5 into Laplace transform of cos 2t plus Laplace transform of e power minus 5t plus 7 into Laplace transform of sin h of 2t. Okay, we know Laplace transform of t power n is nothing but n factorial divided by s power n plus 1. Okay, so the Laplace transform of t power 5 will be 5 factorial divided by s power 6 plus 5 into, we know L of cos at or cos kt is nothing but s divided by s square plus k square. Okay, this is right. So we have L of cos 2t is nothing but s divided by s square plus 2 square, right, plus L of e power minus 5t. We know L of e power 8t is equal to 1 by s plus a, or sorry, s minus a. So we have this is nothing but replacing a by minus 5, we get L of e power minus 5t is nothing but 1 by s plus 5 plus 7 into L of sin h 2t. We know Laplace transform of sin h kt is equal to k divided by s square minus k square. So we have this is nothing but a 7 into Laplace transform of sin h 2t. So this is 2 divided by s square minus 2 square. Okay, so this will be the Laplace transform, that is 5 factorial divided by s power 6, that is 5 factorial is 120 divided by s power 6 plus 5 into s divided by s square plus 4 plus 1 by s plus 5 plus 7 into 2, that is 14 divided by s square minus 4. This will be the required Laplace transform of this given function. Okay. Next question. Find the Laplace transform of e power t into sin h of t. Okay, so how to do this? Here actually we can just use the formula for sin h t. We have L of e power t sin h t is nothing but, we know sin h t is equal to e power t minus e power minus t divided by t. So using that we get L of e power t into e power t minus e power minus t divided by 2. Okay, so this is equal to Laplace transform of e power 2t minus e power t into e power minus t, that is e power 0, that is 1 divided by 2. So this is equal to 1 by 2 into Laplace transform of e power 2t minus Laplace transform of 1. Okay, so this will be the required Laplace transform. So we know how to find the Laplace transform of e power 2t. We know this is Laplace transform of e power 2t is 1 by s minus 2 minus Laplace transform of 1 is 1 by s. So this is the required Laplace transform. One more question. Find L of f of t if f of t is equal to minus 1 for 0 less than or equal to t less than 1 and 1 for t greater than or equal to 1. So here we need to find the Laplace transform of this function f of t, which is defined for all t which is greater than or equal to 0, right? And this function is a split function, so this is minus 1 in the interval 0 1, and for 1 to infinity it is 1. So here we can use the definition of the Laplace transform. We know L of f of t is equal to, by definition we have, this is nothing but integral 0 to infinity e power minus st into f of t dt for f of t, which is defined for t greater than or equal to 0. So here we are given that f of t, the value of f of t is minus 1 when t varies from 0 to 1. So we can split this integral as integral 0 to 1 and 1 to infinity. So when t varies from 0 to 1, we have f of t equal to minus 1. So this is e power minus st into minus 1 dt plus integral 1 to infinity, that is in the second interval we have f of t is 1, so e power minus st into 1 dt. So we need to integrate this. So here integral 0 to 1, sorry, integral 0 to 1 minus e power minus st dt plus integral 1 to infinity e power minus st dt. So this is equal to, integral of this is nothing but negative of e power minus st divided by minus s from 0 to 1 plus e power minus st divided by minus s from 1 to infinity. T varies from 1 to infinity. So here we have this is e power minus st divided by s. So this is e power minus s minus e power 0, which is 1 divided by s, plus, sorry, this is minus 1 by s, so minus e power minus infinity will be there. So e power minus infinity, if s is positive, this is e power minus infinity. If you take s is greater than 0, then e power minus infinity will be 0 minus e power minus s, okay, divided by s. So this is equal to, taking 1 by s outside, we have e power minus s minus 1 plus e power minus s. So this is equal to 1 by s into 2 e power minus s minus 1, where s is greater than 0, okay, provided s is greater than 0. So this is the Laplace transform of the given function f of. Now you try these problems to do yourself. We already discussed this problem and this 35, okay, the others you can do, okay. So in this 7th 8th 9th and 10th, here we need to find the function by using this graph, okay. For example, here from t equals 0 to 1, we have the f of t is equal to 0, and from 1 to infinity we have the line, this, that is the straight line passing through these 2 points. So you have to find the straight line passing through these 2 points, etc. Okay,